Unbelievable. Good day, welcome to Great White Retro. I'm Gord Fessick. This is my wife's cat Tai, and she's being a pest. Our topic today is once again the Tigerton lot. We are going to do a massive cleanup today. We're going to get all these cases cleaned up. We're going to see about derusting a little bit, and we'll get the second board working, provided that all the parts that I've ordered are working. Let's get her done. This video is sponsored by my wife Bridget because she generously donated her two lapel microphones from her college days. These are actually pretty good. I'm surprised that they work as well as they do. Yeah, they're just your typical things you can get on Amazon, but at least her generosity has made the audio quality on here considerably improved. Thank you, Bridget. Now, on to the video. So last night I did a little bit of preemptive disassembly. What we got here is the two systems from Tigerton. I have already taken apart the keyboards. I have the keycaps here. I've got all their springs. I've got the spacebar springs and some additional pieces set aside in the smaller container. The RF shields, I need these to use as heat sinks. This one's a bit rusted, but I think I can do something about that. I've also already gone and removed, a little more gently this time, all of the MT RAM and all of the MOS logic from the Aussie case board, because I plan on replacing that with more regular off-the-shelf logic here. So if I have to replace the PLA and I have to replace the VIC chip, let's see about upgrading this to a PAL version. I mean, it's the right kind of sort of case for it. So with any luck, we will follow retro recipes, so we'll do Paraphractics migration to PAL on this particular machine. On the Breadbin, the NTSC VIC chip works just fine, so we'll use that and we'll continue to keep this as a North American machine.
So let's get started. With the machines taken apart, I'm actually going to run them in the dishwasher. I want to get these things as clean as I possibly can before retrobrighting. I even have the keyboard frames taken apart to run through here as well. Now, watching other guys do this, like Adrian Black and his Apple IIc, what he does is he will turn the heat off for drying, he'll turn the heat off for the water. So we're just going to rely on the tap water. We're going to make sure that paper label is off of there for the Aussie case board, right? And I had to go and rearrange this layout several times to get everything to fit. Even the RF shields are going in there because the detergent I'm using has anti-corrosive properties, because you put silverware in here, you don't want it rusting either. I was rearranging, but I was able to get also that shell from the 1541C in here. I got the hard drive, I got the floppy drive shells in there, barely, but they did manage to fit. And it'll get some of the rust off at least, or at least help stop it from spreading a little bit. That was as much as I could cram into there. Yeah, here I am rearranging again, and again, and again. There we go. Bit of Cascade Platinum. No, we're not sponsored by Cascade. Anyway. Okay, so we turn the heat off, and then we let her go. A good 90 minutes later, we come back. I stop it in the drying cycle because I'll just let these things rack dry. There we go. The keyboard frames come out. The RF shields come out. The floppy drive shells come out, and eventually the computer cases come out. I had to do a little bit of extra work on the Aussie case lid because there was still crud in its air vents, but I did get those cleared out. Even after running it in the dishwasher, you can see how yellowed these pieces are, or in the case of the older style cases, how brown they are. There we go. That breadbin is going to be a challenge to Retrobright. If I thought that the 128 was a challenge, this thing is going to prove interesting. But I have a cunning plan for that. Here's the Aussie case. The one that they said wouldn't yellow. Well, it didn't yellow, it turned brown. And I'm drying off the RF shields and so forth. There's from the 1541C. I don't know what I'm going to do with that drive yet, but still, I might as well try to de-rust it some. These keyboard frames definitely needed a good scrub, though. I wish I knew what that hole in the RF shield was for. Anyway, with both sets of keyboard keys in one container, I give them a good scrub, I let them soak for a while, and then I gave them a shake. I get the spacebar stabilizers out of there. We'll give everything a good rinse. These keycaps actually yellowed on the very top, so I gotta figure out how to deal with that too. Get back here. Alright, there's the keys drip drying. Now, I'm out in my garage right now. It is about +5 Celsius outside when I'm doing this, and it was the middle of December, so I'm like, why is it so warm over here? Might as well take advantage of the weather while I can. I give everything a scrub to at least get the loose surface rust off, and then I'm going to tape up the tips of these heatsink tabs so that these will continue to work as heat sinks. The very tips of these tabs didn't seem all that corroded, so I figured they would be okay to be left exposed. Especially the end where the VIC-2 chip gets its heat sinking from. There we go, all masked up, got goggles and gloves on, and I've got some Rust-Oleum rust converter here. Right, what it can do is it can penetrate rust and turn it into something that can adhere to paint so that it acts as a primer. I don't really need the paint. The rust conversion will do. It'll seal these pieces up. It'll stop the rust from spreading further. The vinyl tape tabs that I put on there will make sure that the tips of those are still exposed so they will be heat conductive. I did not have the time to get out an electrolysis kit or to do anything to do with vinegar and salt. Not this time. So I'm like, hey, just paint it black. Actually, I didn't know what color this stuff was going to be, because no one's going to see the inside of this anyway once it's done. After they dried up some, I flipped them over and I took care of the other side. And after about 4 hours, I gave them all a second coat. There were some spots that I missed completely, even though I went in 4 different directions on each piece. I still want to make sure these things were fully coated in the rust converter primer. Eventually, though, we did get this. Yeah, hopefully this is a little less extreme than what I did with the Commodore 16's RF shield. Maybe I'll take the 16's RF shield and do this treatment to it. I would have to get all the oil off of there from the lubrication that I put on there for rust proofing for this to work. But hey, why not? I might just do that. And while those were drying, I took these cardboard separators and I covered them up with vinyl tape. They had some rust on them as well, and I didn't want that coming off. I didn't know if I could really paint these. I didn't want these cardboard pieces soaked in rust converter primer or any other kind of paint. I ran out of the black vinyl tape, but I found some pretty colorful stuff to use in its place. The colorful stuff turned out to be a lot thinner, so in hindsight I probably should have used the thinner tape instead of this stuff. It did fit though, and I was able to use hole punches to punch the screw holes out of the vinyl once it was fully adhered and flattened out. Here are the keys. You can see on the F1 key, the printing on the side is brighter than the printing on the top. That's actually part of the plastic mold, I'm guessing. So I'm going to have to apply peroxide to the tops of all of these keys. This is that peroxide flour paste that I made last time that worked on the PetStyle VIC-20 and also worked on the Macintosh SE. I figured this was a lot easier to deal with than trying to soak or boil these things in peroxide. I did not want to boil any more keys. It would have helped if I kept the keys flat when I wrapped them up in cling film though. There we go. All of the keys from both keyboards are in this tray, and they're going to go under my UV lights. So this is the board out of the Aussie case. I've already removed the Moss branded logic and replaced it with standard logic. I've got bus multiplexers. I called them bus transceivers in a previous episode. So I got these, and I've got a hex inverter there. These are the standard parts. The only Moss branded parts in here right now are the custom chips. I just got to figure out now, how am I going to get an 18-pin socket into a space meant for a 16-pin socket? Could do the crazy bodge that I did in the previous episode. I'm thinking, let's see if we can do a proper job. And what I've got here is a cordless Dremel. What I'm hoping to do is to add 2 additional holes near here, and then I can also use the engraver to eat away at the solder mask and at the 5-volt and ground traces underneath, so that I can then just bodge another socket in there, and I'll just use wire wrap wire to make the connections underneath. Not quite as simple as the Commodore 16 upgrade, but also not quite as crazy as the wire mess that I have on the Breadbin board. I really don't want to leave it in this state, even though this works. So how do I try to explain this? On the bottom of the board, I need to identify U12 and U10. I need to drill 2 holes here and here. I'm also going to have to watch out for any traces that I cut when drilling these holes, so I'm going to have to cut those traces around them, and then I'll have to rebodge that line later. I'll then have to eat away at the solder mask around these other spots here so that I don't cause any short circuits, because some of those pins are originally ground pins, and that's just not going to work. On the other side of the board, it's a pretty similar story, and it's identical for both sockets. I'm going to have to cut this line here. That's the line between pins 2 and 14. Those are the shared data lines. I'm going to have to clear the solder mask around all 3 of these pins. What's going to become pin 17, I don't want to be grounded. That's going to be one of my data lines. And around pin 1 and 18 are going to be ground anyway, so I just need to clear the solder mask. I don't need to cut those lines there.
Feel like a dentist. Oops. I think the holes need to be a little larger, but we'll try test fitting our sockets. Whoops. Let's get that out of there, try again. I'm gonna bodge it anyway, but still, be a good idea to get the holes right. And that one's over on the other side. Well, we can have it match. Fortunately, this is all ground and power planes anyway, and I'm gonna try to clear around these spaces. Okay, there's one. Well, those fit. So there's where I can put the 4464 sockets, and they match the same positions as before. Now I just got to make sure that the area around my pins is clear. Although the ground pin, I can go to ground with it. So let's see. I've got the engraver tip on here, and I am hoping to eat away around this ground pin here, and make this the new ground pin. I'm also going to have to eat away at this trace because it's now in the bad spot, and I'm going to have to bodge that. Here I gotta do the same thing, and here I just gotta be careful. Let's try this side. Whoops. Yeah. Careful of the other parts nearby. Okay, let's see if that was enough. It's still grounded. I wonder where from. All right, that looks very clear. Let's try now. There we go. Let's check other pins. Okay. That's no longer grounded. That's grounded. But that's the output enable anyway, so I want that grounded. So I think I might have this one. I just got to do this one over here and then follow up all the way around. So that's ground. The one beside it is also going to be ground because that's output enable. Okay, well that was different. So on the second RAM chip, that's our output enable, and it's going to be crossed up with these other ones. So I'm going to make sure that these are disconnected. And I will bodge them up later. Once again, 2 and 14 I'm going to have to sever. We're still connected to ground here. Must still be connected on the other side. Alright, they are no longer connected. Okay, and our new ground is available. Our output enable is isolated. I'll bodge that to ground. Our no connect is here. I just got to worry about pins 1, 2, and 3. 1, 2, 3. 3's nothing there. And we've got our new ground. Both of the first first and last pins are going to be grounded anyway. The second pin is a no connect normally. Alright, let's get that socket in there. Let's fix what I cut by accident and do the rest of the changes.
Here I am. After I've soldered these sockets in place, I check to make sure that they're flush. I do just the corner pins first, and then I give them a push while I have the soldering iron on, and then they fall into place. Then I solder the rest of the legs in place. Here's the underside of the board. These bodge wires are run very much like the hack job that I did in the last episode, except I've got this extra data line going up to a data line on the ROM circuits directly above. They are supposed to be common. Let's take a closer look at this modification. Pin 1 is output enable, and we leave that to ground. Pin 2, which is D1, goes to either U21 or U23 pin 2. Pin 3, which is D2, goes to either U22 or U24 pin 2. Pins 4 to 14, including the 5-volt line, has no changes. Pin 16, which is D3, goes to either D7 or D3 lines up on the ROMs above it. Pin 16, one of the refresh lines, is not changed. Pin 17, which is D4, goes to either U9 or U11 pin number 2. And finally, pin 18 goes to ground. Cut away any traces that interfere with this particular arrangement. Here we go. Oh, that's interesting. Nice! 38,911 basic bytes free. Let's give this a proper test. Let's get that VIC chip out of there. Let's put back the original VIC chip to see what we got. There's the original PLA, right? But I'm going to show you what happened when we put in the original VIC chip that came with this machine. It's going to have the wrong colors on it. It's especially going to have the wrong colors for everything because I don't know if you can notice from here, but there's a problem with how I inserted that VIC-2 chip. Uh-oh. Oh well. Let's get our RAM in there and see what happens. Absolutely nothing. And for a good reason, I shifted the whole VIC-2 package over by 1 pin. Ouch! I mean, in some versions of this chip, there's 12 volts going to some of those pins, so I'm hoping that I didn't break the chip by doing this. Fortunately, I did not. And there we go. There's our basic screen. All the RAM looks good so far. I got the diagnostic cartridge in there, but without the harness attached, this can at least test the RAM to make sure that it's behaving. Here I am going, come on, come on, until finally, yes! Let's get the harness hooked up. Aside from the custom chips, this one is MOS logic free. There's all standard logic on here. There we go! I dare say we have a working board. Let's put in the other VIC chip, and you can see what's going wrong. Yeah. So, I mean, it still works, kind of, but it's the wrong color. white is supposed to be white and black is supposed to be black, and that would make using the dead test cartridge rather difficult, which is probably why it gave us trouble. Since we're here, let us try out this nice shiny new PLA that I got from Hungary. But at least we can put in a good new PLA. Well, sort of. You know, it's a PLA. What do you want? And we'll give it a shot. This'll do for now. Let's clean this up and we'll pick this up tomorrow. Alright, while we were working on that, these keys were cooking downstairs. And, well, they're not perfect. I think they turned out good enough, certainly compared to what they were. Like, that plus sign might be a tad yellow yet, but I don't believe anyone would notice on casual inspection. I give all these keys as good of a rinse as I can because that peroxide will wreck your fingers. There we go. Give everything a shake, I let it rest, and then I come back and rinse it off again. So the tops of the keys turned out quite well, in fact. Next, let's work on these cases. This is the brown breadbin, the one that was simultaneously browned and faded. I figure let's get the whole thing faded, or at least get it one color, or one pattern, or something. We can deal with any side effects of the retrobrighting afterward. There we go. So my peroxide paste and lots of cling film, right? And then it goes under the UV lights just where the keys came from. The Aussie case is a little more interesting, not because it was bigger or smaller, but because it has very distinctive marks of where it turned brown and where it did not. I am likely going to see this thing become really white in spots that weren't quite as browned, and maybe the spots that were browned still a bit yellowed. We'll see. We can always send this thing back, or we can do submersion afterward. But I was almost out of peroxide. I had to make use of the peroxide I had as efficiently as I could. And this was why I ended up making more of the flour paste. I've got more projects I want to do with this bit of peroxide yet. I've got an Atari 800 that needs some retrobrighting badly. While I did get one of these ends folded up, I ended up missing the other. So I've got another Sucopera device here. This is a 27 series EEPROM adapter that should work in the older Commodore 64s. I got this from the Brewing Academy, same place where I got the Ultimate Atari video adapters, but they have pre-assembled it to only take a 2764 EEPROM. I don't have those. I've got 27 256s. So I am going to have to remove two of these 0 ohm resistors. R1 and R2 are going to have to come out. I'm going to have to somehow install larger resistors in their place, but they are through-hole resistors, they're not surface mount resistors. That's going to make things pretty challenging, but if I can figure out where these signals go, then I should be able to add the resistors anywhere in here. And I'll have to do this twice, because I've got two C64s to do it for. And then later on, I've got two 1541 disk drives to do it for. This is so I can get Jiffy DOS working. And I'm also going to preload the dead test cartridge on here. We don't have something like the Diag 264 like we do for the TED-based machines. But dead test resides in the same space where the main firmware does. So, in theory, it can replace the main firmware. At least for the purpose of testing. Otherwise, I've got the regular 64 firmware and Jiffy DOS firmware on these two EEPROMs. Let's do some hacking and see what we get. So yeah, I mean, these surface mount resistors come off with just a little bit of heat and patience. That's not so bad, right? but I didn't know how I was going to replace these, at least at first. But once I found out where the signal lines were going, it wasn't so bad. I was able to come up with a plan to run some 10K resistors, through-hole resistors, to the needed pins.
If it's stupid but it works, well then it's still stupid if you ask me.
Let's see if we can get our Brewing Academy EEPROM working. We'll pull out the existing firmware. We'll put in one of our two devices, and like on the other machines, I'm probably going to have to desolder the existing socket so that this contraption can fit. Let's try it without jumpers right now. We get nothing. Oh, it's the dead test. Okay. Here. Let's put the other one back. Let's make sure that dead test is what comes up. Okay, alright, thank goodness. You know what, since we're here, let's give it a try. And I gotta tell you, these round pin sockets are a royal pain. I was sitting here with my little screwdriver trying to push individual pins there, and I was kind of channeling my inner lock-picking lawyer. You know, nothing on 1, 2, oh, binding on 3, nice click on 3, for nothing on 4, 5, 6, nice click on 7. Brewing Academy, please consider putting double wipe sockets and allowing these things to be a little more configurable when you put these together. Thanks so much. Let's let this go through its test. This behavior with the screen RAM is just neat. That threw me for a loop the first time I ran through dead test, thinking that my board was cooked. But nope, it was actually working as intended.
It just takes a bloody long time for it to finish the RAM test, so you have no idea what's going on in the meantime.
That's encouraging. Okay. And I've made myself some jumpers here. Let's try the outer one first. It's still dead test, I think. Okay, alright. Alright, let's try the inner one. Hey, we got Jiffy DOS. The only thing we're missing is the stock firmware. If I rearrange the images on these EEPROMs, I might be able to get it more switchable. But in the meantime, I'm grateful for Jiffy DOS and dead test. Let's try out the other board. Put in our little tower of power here. And we'll put in the short jumper for now because I'm pretty sure that's Jiffy DOS. Yeah, that's our white VIC-2 chip here. Okay, there we go, Jiffy DOS. That was expected. This is going to linger on a white screen longer because I think this is the dead test image. Yep, it's the dead test image. Okay, so I just need to do some rearranging on these ICs, on these EEPROMs, and then I should have it switchable between dead test, stock, and Jiffy DOS. But we're not done with this board yet. You notice we've got a VIC-2 chip that's got a problem with black. Well, we do have another VIC chip now. It is actually a PAL VIC chip, which means I'm going to have to replace the VIC-2, the crystal, and I'm going to have to jumper this connection here. So let's convert this into a PAL machine.
So, I'm gonna spare you the struggles that I had with this thing. Desoldering the signal legs for the crystal was pretty easy, but all of the signals around the ground plane were really difficult to clean up. There's just so much metal, and even the new soldering irons I had couldn't put out enough heat to do this properly, so I kinda had to cheat a little bit. But I'm attempting to do a layout very similar to the one I did on the Commodore 16, with 2 pins out of a 6-pin socket, and then a single pin header there for the top, for the ground, for grounding the can of the crystal. That's a 17 megahertz crystal, exactly like the one I used in the Commodore 16. All I'm doing here is I'm using the leg of a 1K resistor. I'm not even using the resistor itself, I'm just going to use the lead from it. And once that's soldered in place onto the can, I snip it to fit. And now I just install an extra pin there so that I can jumper between the NTSC and PAL jumper position there. And there we go. Alright, that should be good to go. And I just stick another handy spare piece of resistor lead to make that connection. So now this is reversible. And finally, let's remove the NTSC VIC chip and put in our fresh from Hungary VIC-2 chip PAL version. These are the same series of VIC-2 chips, so they are compatible. Now, firing it up for the first time, well, this particular TV doesn't seem to understand PAL video like my big Vizio monitor does. But you know, that's okay, I can deal with this. Yeah, there's dead test. But we do have other display options. Let's get one of the monitors we were using at VCF and at Collectorabilia here. Right? That's capable of doing a PAL display. There we go. Fire this up again. Come on. At least the display is now black like it's supposed to be. And there's dead test. Alright, we let dead test run at least once, and it was successful. I just can't get enough of this melting effect.
And there we go. We've got a PAL machine. So let's take you on a tour of the board. We've got our replacement RAM here, 4464s. We've got these bus multiplexers replaced with stock ones. We're not using any MOS logic. We've got this hex inverter replaced. I think that's a hex inverter replaced with off-the-shelf logic. We're not using MOS logic anymore. We have our Sucopera ROM switcher here, and we've got 4 modes here. 2 of them are occupied by the same thing, which is the dead test image. I found out you had to short the remaining 2 pins together to get the third firmware, but that's fine. We've got a PAL VIC-2 chip here. We have a PAL crystal. We've got this shorted here, and this is reversible now, so I could replace this crystal with an NTSC crystal, I could remove this jumper, and I could swap in an NTSC VIC-2 chip. So we got that. Right now we're in PAL mode, and we should be in Jiffy DOS mode. And we are. Let's swap that out with the one that shorts out both of these. This should take us to the stock firmware. And it does. Okay. but we're not going to really need that. And you've already seen the dead test. So let's see about cleaning this board up. I still have to use some alcohol in the back to get all the flux off. And I think I am done with this board. I'm going to do very similar things to the other board, except I'm going to keep it as an NTSC machine. Okay, this is the board out of the bread bin. It too has a pair of 4464s. It has the Moss branded logic removed. It has this socketed in here, but I had to solder the adapter into place. It has an NTSC VIC chip and crystal, and it's running, well, it was running dead test. It must be doing the full RAM test right now. Let's give it a bit. And there we are. Okay, we'll make sure we got Jiffy DOS. There we are. It is switchable to the stock firmware still. There we are. And there we go, stock firmware. I'm going to put it back into Jiffy DOS, give the board a clean up, and then we can put it back together.
Welcome to my basement where I've got my Retrobright set up. And, well, let's turn the UV lights off to find that the bread bin is, well, on its way. It's not quite there yet, but I am going to come back down here later and kind of touch it up. The Aussie case, on the other hand, has some major problems, mostly because I left the ends exposed and not wrapped. So that accomplished nothing on the ends. Oh well, let's at least open up these things, we'll get them cleaned up. It's the end of the day at this point, and all we can really do is rinse them off, clean them up, get them ready to go back into the UV lights tomorrow. However, the bread bin is in much better shape than it was. This needs to be touched up here and there. So, this is looking pretty good. Nice. Now on to the Aussie case. This one, yeah, it disappointed me, but I expected as such considering that I left the end exposed. You can see a border between a yellow part and the white part there, or the tan part. There we go. So we'll get these halves together and you can see much clearer what's going on. I ended up putting both cases back under the UV light the following day to touch these areas up. Now, let's get these things put together. While we were retrobrighting downstairs, I put these two keyboards back together. Now, I've got a mixture of long and short plungers. Both of the caps lock mechanisms were identical though, so I think I might have swapped some keys around, or at least some plungers around when I shouldn't have. But I was trying to be careful to make sure all of the slightly longer stems ended up in this keyboard. Even though I did that, there was still some longer stems left over when I was ready to put the second keyboard back together. So I'm not sure what happened there. But still, I put them in anyway, and it seemed to be okay, I think.
So I've put in all the long keystalks, but I've got some long keystalks left. I wasn't expecting that. I guess it's possible that there is a mixture of long and short keystalks in one of these two computers.
Not to mention that these circuit boards are slightly different. One of them is exposed copper, well, gold-plated copper, and the other one is using carbon contacts on the circuit board. I might have to go back to one of these keyboards to try to sort out the contacts, but it seems to work good enough once I put them back together. Now here I'm putting in a million little screws, and let's get that spacebar in there, or at least trying to. Spacebar, stabilizer turned out okay. Yeah, let's get that in there. I didn't realize that this thing gave me so much trouble. Come on. Yep, off and on, off and on. Why am I having such a hard time with the spacebar on this thing? That photo I got up there is from the Pet Style VIC-20. The key layout is identical, so I just used that. I think I finally got it. Yep, there we go. I had a problem with the key montage that I wanted to do. The frame for my camera started slipping sideways, so I'm like, oh boy, whatever. Let's just get this done. Anyway, let's put the breadbin back together. After another run of Retrobright, you can see that it's marbled a bit, but I have another cunning plan for dealing with that later. Let's at least get this thing back together. It's certainly not yellowed anymore, and if it's not yellowed, that means that we can fix everything else. I'm pretty sure I got these two keyframes reversed though. This one looked like it actually would fit better on the Aussie case. They're supposed to be interchangeable, but I struggled putting the Aussie case back together. Anyway, here's one of the two RF shields. You can see the rust converter is covering up the rusted bits. They're a slightly different color. There's my Technicolor tape. How 1980s is that? Anyway, we'll get the bottom half of the RF shield in there. The holes weren't quite big enough, so I stretched them a bit. It's just vinyl tape. There we go. Now the board itself can go into place with its connector side plate there. And I recovered several screws from that Apple IIc case. It turns out these screws are identical to the ones that Commodore would have used for mounting these boards. So I put some heatsink compound on all the chips that could use it. I put in a couple of screws to begin mounting it in place, and then the top half of the RF shield, well, it is a heatsink as well, gets put into place. Some of these were busted off, so I wound up using self-tapping screws to kind of drill a hole in there. And then I used longer case screws to fasten it. That meant that the screws stuck out a little bit out the bottom of the case. What I think I'll do later is I'll take the Dremel's, one of its rotary tools, to file down the ends of those screws so they're at least flush. But hey, we got no more self-tapping screws, no more sharp screws being used in this case if I get my way. And when it's mostly assembled, oh, it's the monitor's in PAL mode and we're trying to use an NTSC computer. Let's switch it back. There we go. I still quickly power cycle the monitor to center the screen a bit. Come on. There we go. One last diagnostic before I remove the harness and install the keyboard. And it's all looking good. A second run turned out just as well. Alright, let's get this keyboard reattached. We'll get the shift lock reattached. I left that just in case there were keyboard problems, which there were not. Finally, the power LED can get hooked up and we can close the lid on this breadbin, at least for now. And we're using proper case screws. We've actually got all the case screws, not just self-tapping ones. And well, what's a Commodore 64 without its label? These are those Polish labels that I ordered for the Commodore 16. I do believe it is now finally a Commodore 64. Alright, let's launch something off the SE to IEC to give it a proper test. And well, look at what time of year it is. Why wouldn't I run the Commodore Christmas demo? Somebody get the snowplow to brush off all those periods. Here's a before shot from when I brought this thing home from Tigerton. And here's the after shot. A little marbled, but we can fix that later on. Now for the Aussie case. I'm using double-sided tape to put the Made in South Australia label back on there. This is not the tape that I used before because I seem to have lost my razor knives. Well, let's get this on here and we'll be able to cut off the excess adhesive once the label is in place. I used the spatcher from my precision toolkit to smooth everything out. Yeah, the back of it was torn a little bit, but the label itself seemed fine, and once we get this in place, I don't care about the back of the label. It's going to be fully fastened in place. There you go. Produced in South Australia. Not something you see every day anymore. Let's get the bottom half of the RF shield in place. Here comes the jet black separator. And finally, the PAL version of our board. We got some placeholder case screws in there. This is a little different because two of the case screws actually fasten to the top half of the case, so I can only fasten so many screws. Yeah, those two there have to be fastened in as part of the RF shield, so I wind up taking off the tape there we go, opening up those, and those metal bits are now exposed so they can act as proper heat sinks. A little bit of heat sink compound on all the chips that need it. The RF shield itself can go into place, and I can only fasten the two bottom screws. I can't even fasten that one top screw, even though you're supposed to, because the ROM switcher is in the way. Let's get the LED cover in there, and let's get the LED itself snapped into place. It held in there without the need of the extra snap. That's how strong this LED holder was. Get the keyboard mounted. Now this was the keyboard from the Breadbin. I had to unloop that ferrite bead to make it fit inside the Aussie case, but I managed. So I kind of start those two screws, let them catch onto the RF shield, and then I can mate the two halves of the case together a little better. So I kind of had to do it in that order for the top half of the RF shield to stay in place. But after that, I could get those last two RF shield screws in place, and then I can get the whole rest of the bottom screws on the front there. And once again, these are all proper Commodore case screws because I had all the extra board mounting screws from the Apple IIc. All done. Let's put the monitor back into PAL mode now. And there we go. There we are. Ta-da! Alright, American Commodore 64, you wanted to be Australian so badly. Now you're not only Australian, but you're a PAL machine. Let's see if we can find some PAL demos to run on here. Well, the only thing I had handy was from the Great Guiana Sisters. The majority of the copies out there are PAL versions. There is an NTSC fixed version, but this one here demonstrates that this is working with PAL timing. Wonder if I can find Sam's Journey on floppy disk or on disk image. Bet that would work. Here's the before shot straight from Tigerton with its very yellowed case and dirty keys. And the after shot, which might not quite be done yet, but we'll give it a touch-up in future episodes maybe. This is looking much better, and working much better too.
Well, I really wanted to end this year on a high note. And while we only got half of the Tigerton lot working, we did get both computers working. And we even managed to convert the Aussie case machine into an Australian computer by running PAL on it. Next year, we're going to take a look at some more Atari stuff. I'm hoping to do that. I'm going to see if I can correct the marbling that got done on some of these cases. I've got some crazy ideas for that. And we'll see what else we can get into next year. Until then, Merry Christmas, Happy New Year, and good day.